Hey, what's going on, guys? Coming again here. In this video we're gonna build a clock that can be used along with an 8-bit computer, and it's based on LM555 integrated circuit chip, a very popular one. So this is the entire schematic that is actually making this LED blinking. So the pin number three, which is the output, we have this LED being connected, and at this pin we actually have the digital signal, which later can be used in order to synchronize the rest of the parts of the entire 8-bit computer that we can potentially build using this tiny little clock. So let's actually build this from scratch, and meanwhile we'll learn about the 555 chip, how it works, so which pins we use as an input, how we can change the frequency of this LED flashing, or literally it's just an indicator. So it's what we actually manipulate is the signal, right? And the faster it starts to flash, the faster our 8-bit computer would be potentially, and the slower it flashes, the longer it takes to complete a single cycle. But it might be really good for debugging, so if you want to see how things work on the lower level, so it doesn't go that fast, so you can see and you have a chance to figure out how everything is actually working. Okay, guys, so this is what we're supposed to be building in this video, and without further ado, let's actually start. So I'm using tinkercad.com website. The link would be in the description below the video. It's totally free. All you need is just to sign up, and this can be done using a Google account, for instance. So this is very simple and straightforward. And once you've done, you're getting into the dashboard, and here you have a button, create new circuit. So let's start by creating a new circuit here, and it takes a while to load the environment, but once we're done, we can actually create a breadboard. So I'm using this breadboard small. All right, okay, here it is. And obviously we need some power source, so let's search for power supply. So power supply, and we can zoom using the mouse wheel, by the way. We can nicely centralize it. So let's take a power supply, all right, and I want to bring it sideways here, for instance. Okay, and we have the positive and the negative pins of the supply. So we can now connect the wires to our breadboard. So let's connect -1 here, and we can also make it a nice shaped, and let's make this one black, and also we can bring the positive voltage here, and let's make it red. And now to power the rest of the breadboard, we can also forward this like here, all right, and here, all right, and let's make it black. Okay, so now we need to make sure that our power supply is actually working. So let's burn up an LED to make sure this is so. So just grab an LED, put it here, and I want to rotate this slightly a little bit. Yeah, now it's rotated. So we need to put the anode to the positive wire, and the cathode to the negative one. So we just plug like so. This should be fairly enough, and if we run the code, we should now burn this LED, and we do burn the LED. And that's happening obviously because the current that is flowing through this LED is much bigger than the LED can handle. So we can use the resistor to handle this, but not at this point. not now. So instead we can actually use a voltage, a voltmeter, and we have this nice little multimeter available here. And we just let's see, put it like so, and again, like I can just well, let's actually put it somewhere. Let's put it somewhere like this for now, and like this, and make it red, right? And put this one here, okay, and okay, and then make this one black. And we can even put it, for instance, here. Okay, so if we now power our circuit, we see that we have 5 volts, which is great. So from now on, we can actually start building the clock. And the clock is going to be based on the 555 timer. So here is the chip, and I just plug the chip in. Well, the good practice is obviously to have a look at the datasheet, but this program is good enough. Is nice because we have all the pins being labeled, so we know which one is which, and we can actually start connecting. So connecting this, start embedding this chip into the circuit. So the very first thing to consider, we want to power it up. So here we have the plus 5 volts, and here this pin is accepting the plus 5 volts, while this one is considered to be the ground, and we suppose that the negative wire serves as the ground. I'm sorry for maybe I explained this a little bit wrong. I'm not an electrician, I'm a programmer, and I'm pretty new, I'm completely new to all of this stuff. So don't judge that much, please. So I just want to so here now we've powered this pin, and now I also want to power this one. But again, like here is, so this one is connected to the ground, but actually it's connected to this minus 5 volts, which is treated to be the ground. Okay, so in order to control, so well, let's probably start with an output. So the output digital signal is going to be generated here. So we need to connect an LED between this output and the ground. So let's actually create the LED again. So if we just grab the LED here and plug it in. Actually, I want to rotate it so the anode goes to the left and anode gets connected to this output. This is important because if you just put it the other way, so first of all, LED is a diode, and in the diode the current can flow only in one direction, and if it goes from the opposite direction, this is just not going to be working. It's just going to be treated as the absence of the chain, right? So let's plug our LED somewhere. Well, for instance, let's plug it here, for instance. And now we need to connect this the output pin with the anode, and cathode should be connected with the ground. But we also need to put a resistor there to make sure that we're not going to be burning the LED one more time. So I just connect these guys. And well, probably yeah, I'm just looking for a nice way to represent this. Yeah, probably, yeah, okay, this should be just fine. All right, and also let's create a resistor. So resistor, right? So this one should be okay, this is 1 kilo ohm. We don't need that big, so it's fairly enough to use 220 ohm resistor, right? And it gets, so this tiny little stripes are getting different colors when we adjust this. I have no idea how to read this, but those who can read this, it makes perfect sense to them apparently. So let's rotate the resistor like this, and let's plug it in, let's say here for instance. And now we need to connect this these two elements, so let's just provide this connection here. Okay, and then we need to connect the resistor with the ground like this. So we've just built the output part, and now all we need to do is to figure out how to manipulate the input voltage to get the different timing of this LED to be flashed on and off respectively. So all we need to control this 555 timer is 2 resistors and 1 capacitor. And I'm not going to be diving into the details of how exactly this works, and you would rather watch the video by Ben Eater, who explains this in great details. And from my side, I would just rather just go and build this missing parts. So we're looking for a capacitor, and we need this one, which has the positive side and the negative side. Okay, so now we need to rotate it so that the positive side goes to the pin number 2, which is the trigger. All right, so I just put it here, and the second pin should be connected to the ground, and I just make it gray so it mimics like as it was a pin of the capacitor. Just looks a bit better, I believe. Okay, and now just to make it work, so we need 2 resistors. They are called in the data sheet, they are called resistor A and resistor B. But in order to have, actually in order to manipulate, just before I plug in the resistors, I just want to say that in order to manipulate the speed of this LED kind of like blinking, right? Or actually this is just the indicator of the digital signal. So if we want to manipulate the frequency of that signal, we can do this by changing the value for the capacitor or for those 2 resistors that we're going to plug into our circuit. But the way how Ben Eater does this is actually we have a fixed capacitor, a fixed resistor A, which we'll now plug in, and then we have resistor B as the variable resistor, and we can even replace this with a potentiometer later on, which we'll do in this video as well. So the first resistor should be 1 kilo ohm, and this is relatively miserable. Now the second resistor, so let's make this 250 kilo ohms, right? So now, and this one should be 2 microfarads, and it should be working with a 5 volts. Okay, and now by only changing the resistance of this resistor, it's fairly enough to change the frequency of this LED blinking, right? So now we need so again, like this resistor is known as the resistor A in the documentation, and we need to connect it to the pin 1, 2, 3, 4, 5, 6 to the pin 7, which is called discharge, right? And then between the discharge and the threshold, we need to plug in what is known as the resistor B. So I just connect this with here, with the threshold, and then I can plug the resistor in like this. Okay, and the very last thing to make it work, we actually need to connect the threshold with a trigger. To be honest, I have no idea why do we need to do that, but that's what is stated in the documentation. That's exactly how it works in Ben's schema. Okay, so let's just make it like so, and like this, and let's make it green. All right. Okay, so now if I made everything properly, if I run start simulation, it should actually start blinking, and actually does blink, which is good news. And now what I want to show you is by changing the value of this capacitor. So let's put it to say 300s. Let's stop the simulation, start again. So in theory it should be blinking slower. So let's try 500s for instance. Let's try again. Yeah, now it's visibly slower. And for instance, if we make this only, let's say 100s kiloohms, it now it blinks faster. Okay, so the program might be laggy, and because of the video recording software, it might not be might not have the perfect timing. But anyway, we see that the LED is actually blinking. But we don't really care about blinking, and it's not made for the purpose of blinking the LED. It's made for the purposes of having a digital signal of some sort in some form. And we have, if we want to visualize this, and this might be really useful sometimes, we need what is known as oscilloscope. So let's bring one right over in here. Okay, and I just want to adjust the picture. So in order to plug the oscilloscope, I just want to connect the negative part with the ground, and just to draw this nicely. So let's say just make it like this, and then the positive wire is going to be wired to the output, because I'm interested in knowing, in measuring the signal at the output. So I'm connecting this to the output pin, so 1, 2, 3 to the pin 3, right? And let's make it red as well. So now if I run this stuff, it should, yeah, and now it actually prints. Now it actually draws the signal that we have. So here we have, like, it's not 5 volts, it's apparently 6 point something, like 9, 6.8. We can actually measure that as well. So yeah, let's play around with the voltmeter a little bit. And here the voltage should be changing from somewhat around 0 and up to 2 volts, because that should be, yeah, so from, yeah, it's going almost up to 2 volts. Yeah, probably it just goes too fast. So yeah, probably if we just make this, yeah, actually here it was also fine. I believe just we want to make it blinking slower, and yeah, so you see, like, it goes to almost 2.1 volts, and then goes to 0. And well, there is some time to go from high to low, but anyway, so I hope you get the idea. And yeah, and if we, so here we are measuring the voltage at the output pin, literally, so because this LED is connected to the output. We could actually put this just to make it a bit more logical and accurate. We can actually put this to the pin directly, and let's add another, yeah, let's make another pin, like another node in the path like this. All right, and we don't, so here it should be the same, but we don't really care about the voltage at the LED. I just wanted to show you that it's no longer 5 volts, hence the current that is flowing through this LED is less, hence the LED is not burning. But let's actually connect this to the ground instead. All right, and just want to make it like so. Start the simulation, and now we're going, yeah, from 0 to almost 5. It's actually 4.8, right? So we can make it even more slower. So let's make it 550 kilo ohms. Now it should be slower. You see, like, now it's visibly slower. So all right, and it just doesn't go to the 5 volts. It just stops at somewhere, which is which is treated to be 4.81 volts, which is okay. All right, so far so good, but again, like the very last thing that we actually want to have here is to make this to make the input to the threshold be invariable. So we still keep the resistor, but we just turn this resistor into 1 kilo ohm, which is again like as miserable as this one. But this is needed in order to, so if we potentially have the physical potentiometer that varies the resistance from 0 to some value. So if we go to 0, then we'll find ourselves in a situation when there is no resistor at all, which might lead into trouble on the real circuit. So just to avoid that scenario, we still have this tiny little resistor. So it's kind of like the smallest, it's kind of the minimal threshold that we allow. So what I want to do now, I want to create the potentiometer, which might be treated as just like as the variable resistor, and I plug it somewhere to not overlay with some sort of existing pin. So here, for instance, here should be fine. Okay, so it's kind of blinking too fast. Now it's blinking slower, right? And now it's blinking even slower. And the signal is changing depending on this variable resistance that I provide here. It's not that slow enough, so if we actually increase the value for this to say 500ths, or just even better 1 mega ohm, I believe. Oh, what have I done? Oh my god, I needed 1 mega ohm. Okay, so if we set this to 1 mega ohm and try to run again, okay, so say like now it blinks much slower, so we can still make it blinking quite fast here, but now we can make it really slow, so there is enough time to see how the entire thing is working. Okay, and if we increase the resistance of this potentiometer even more, then we can have this clock cycles to be even longer. All right, so this is it from my side, guys. Until next time, and take care.